So we have f of x, which is x plus 2, and we have g of x, which is x squared minus x plus 2. And we're asked to find the g comp f of x as the function first, and then g comp f of 0. Good. So I'll start with g comp f. G comp f of x is g of f of x, which is g of x plus 2. I have to replace f of x by x plus 2. And then in x, in g, I replace x by x plus 2. So I have x plus 2 squared minus parentheses x plus 2 and plus 2. If I forget what I like to call jokingly the torture from the very beginning of the class, then I'm in trouble. Because if I don't write 3 terms here as x squared plus 4x plus 4, the whole thing will be wrong. Please remember, a binomial squared has 3 terms. Now I distribute negative x minus 2 and plus 2. Negative x minus 2 and plus 2, these two go away. And that's not a good color per se. And this is x squared, and then plus 3x and plus 4. In this function, I will plug in 0. G comp f of 0, 0, 0, 4. Anything else? Anything else?
Can you go to number 4, the factor theorem part of it?
You said number 4?
Yeah, the factor theorem. It's like 2 different questions.
Number 4. Divide using long division. Present the answer clearly is okay. Very good. Yes, I'm happy if you use the synthetic division when it's applicable. Be careful because it's not always applicable. So in this case, we have 2x squared. No, it's 2x cubed plus x plus 3 divided by x plus 1. Descending order, yes, but there is a missing term at the top. And the missing term is for x squared. So plus x and plus 3. And x plus 1. X times what is 2x cubed? It's 2x squared. At the top, I don't lie, so to speak. 2x squared times x is 2x cubed. Subtract. 2x squared times 1 is 2x squared, but subtract. Change the sign, in other words. Bring down the next in line. Negative 2x squared plus x. Again, I don't lie at the top. X times what is negative 2x squared? The answer is negative 2x. Please make sure that the degree here decreases. Otherwise, it will be a terrible mistake. Negative 2x times x is negative 2x squared, but I have to change the sign. Negative 2x times 1 is negative 2x. I have to change the sign. 3x, I bring down the next in line. And I'm happy because this is plus 3. 3 times x is 3x, subtract. 3 times 1 is 3, subtract. Yay! 0 remainder. So because the answer is 2x squared minus 2x plus 3, and because the remainder equals 0, then yes, x plus 1 is a factor of 2x cubed plus x plus 3. Very good. Other questions?
It says it's x plus 2, not x plus 1.
No, if you look at the actual.
Oh, I have a typo there. I see. I see. We're not dividing by x plus 2. I'm so sorry. Please correct that. Aw. My apologies. You can also say that x plus 2 is not. But no, this is not what I meant. So if you divide that p of x divided by x plus 2, the remainder will be, I didn't mean to write that. P of negative 2 will be the remainder, and we can determine it. Since it's there, let's determine it using the factor theorem and the remainder theorem. So let's plug it in. Since it's there, it's a good practice. But no, that's not what I meant. My apologies. Okay, so remember how to find the remainder. The remainder, so the polynomial is 2x cubed plus x plus 3. So I plug in negative 2 in this, and you will see the remainder will not be 0. So 2, negative 2 to the third plus negative 2 and plus 3. 2 multiplied by negative 8 minus 2 plus 3. This is negative 16. This is positive 1. And this is negative 15. So the remainder of this division, if we were to divide by x plus 2, it would have been negative 15. So therefore, x plus 2 is not a factor of the top. I turned the mistake in our favor. But no, it was an error, typo, I'm sorry. Very good questions. Anything else? Anything else? Number 8. Very good. 4, 5, 6, 7, 8. Express h of x as a composition. Very good. So we have h of x, which is the absolute value of 2x plus 4. And we're asked to find the inner and outer, so that this is nothing else but f comma g. There is more than one correct answer. Can anyone give us an inner and an outer? Can anyone give us an inner and an outer? It's similar to evaluating. What will I evaluate first? Well, I will have to evaluate 2x plus 4 first. And once I get a number, one single number, then I apply this function to that number. Good. Anything else? Maybe you would like to choose a topic from here. Maybe a circle. We use transformation, so we looked at the problem with transformations. We looked at the problem with the long division. We looked at the problem with f comma g. And we don't have anything else yet. What else would you like?
Number 13.
Number?
13.
13. Okay. It's 9, 10, 11, 12, 13. Yes, perfect. So we can cross this out of the list. Okay, so we have x squared minus 2x plus y squared plus 4y minus 4 equals 0. Perfect. So we're asked, is this a circle? If it is, find the equation, identify the center and the radius, and maybe even graph it. Okay. So I see I have 2 terms with x, and I have 2 terms with y. And there is one method that I said, well, it's not really used for solving quadratic equations, although it can, but it alone cannot do the job. But we studied it a long time ago for this. This was the preparation for this, basically. So remember going through the sequence of steps for the completing the square. The middle coefficient is -2. I divide -2 by 2 and I get -1. And I have to square -1. So when I add 1 to this side, I have to add 1 to the other side. These three will make out this binomial squared. The same thing with this one. The middle coefficient is 4. When I divide 4 by 2, I get 2. And when I square 2, I get 4. So I have to add 4 now to both sides. And now these three terms will be plus y plus 2, everything squared. Yes, this one does not belong here. It has to move to the other side. 4 plus 4 plus 1 is 9. And I'll say yes. This equation represents a quadratic, the equation of a circle. Okay. Now, at this point, I'm able to identify the center, and I'm able to identify the radius. And then I will graph it, assuming I'm asked to graph, but let's also graph it. Can anyone give us the coordinates of the center and the radius of the circle?
It's 1 and -2.
Very good. And the radius is?
3.
Very good. So I start with 1 comma -2. And I plot 4 points. They're all 3 units away from the center. North, east, west, south. So I have 1 here. 1, 2, 3. 1, 2, 3. 1, 2, 3. My circle is not going to be perfect, but this is it. Okay, anything else?
Can we go over finding the inverse?
Of course. This was 6, 7. So let's suppose we have f of x, -2x plus 9. It's a linear function, and we know it's 1 to 1. That's why it has an f inverse. It has an inverse function. In step number 1, I have to replace f by y. In step number 2, I swap the variables. In step number 3, I solve for y. So I move 9 and divide by -2. So y equals x minus 9 over -2. And finally, I just write f inverse. I don't like a negative here. I will put it in front of the fraction line. I may be asked to graph both of them on the same coordinate system. Here's how I do it. When I'm asked to graph the function and its inverse on the same coordinate system, I know that the two graphs must be symmetric with respect to this line. It's an absolute must. Okay, I'm going to get 2 points for the original function because they are lines. For this one, I'm going to say when x is 0, y is 9. So 0, 9. And when y is 0, I have 2x equals 9, so it's 9 over 2. So 9 over 2, 0. I'm going to plot these points. 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 halves is 9 over 2 is 4.5. 1, 2, 3, 4, 5 right here. I draw the line. This is the function f of x, negative 2x plus 9. Can anyone, without any calculations, give us two ordered pairs that belong to the inverse function? This is the inverse function, but we don't need any calculations to determine 2 points for the inverse function. Can anyone give us 2 points? If the original function has 0, 9, and respectively 9 halves, 0, what would the points be for the inverse function? Always. If the original,
0,
say it again.
9, 0,
Very good. And
0, 9, half.
absolutely, they have to be reversed. Excellent. So 9, 0. So this was 5, 6, 7, 8, 9. It's the opposite of this point. My graph is not perfect, as you see. This must also be a point on the inverse function, because if the function crosses y equals x, this point has the same x and the same y. Reverse it and you'll get the same point. And the other one will be here. 1, 2, 3, 4, 5, right here. As you've noticed, my apologies, my graph is not perfect. So this is f inverse, which is negative x minus 9 over 10. These two have to be symmetric with respect to this line, and these two have to be symmetric with respect to this line. Very good. Anything else? Let's get the distance and the midpoint out of the way. Can anyone give us two ordered pairs?